Welcome, curious minds, to another deep dive. Today, we're going way, way back. We're diving into the science behind how our universe likely began, the Big Bang Theory, and our mission really is to cut through some of the confusion, maybe pull out some surprising facts, and just get to the core of what matters about this pretty mind-bending idea. We're working from the Big Bang, universe's genesis and expansion for this one.
Yeah, and it's important, I think, right at the start to be clear, this isn't just, one theory among many equals. It really is the most widely accepted scientific explanation we have for the universe's origin. There's a lot of observational evidence backing it up. It's sort of the bedrock for understanding, well, almost everything cosmic.
Okay, right. So let's unpack this. The name itself, Big Bang, it kind of gives you this image, doesn't it? Like a huge firework going off in space. But I gather that mental picture, it's actually a bit misleading, isn't it? It hides something maybe deeper.
Uh-huh.
So let's go right back. 13.8 billion years ago,
Right.
roughly. What did things actually look like? I mean, can we even imagine it?
Well, look like it's tricky, but we can describe the state. It was unbelievably hot, incredibly dense, and all crammed into this infinitesimally small point. A single point holding everything, all the matter, all the energy that eventually became stars, galaxies, us, everything.
Wow.
And we know this wasn't just like a guess. We have evidence. The cosmic microwave background radiation, the CMB, that's basically the leftover heat, the afterglow from that incredibly hot early phase.
Right, the CMB, that's a key piece of evidence, really helps ground this whole thing.
Yeah.
Okay, so you touched on it, but let's tackle that common picture head on. Most of us think explosion. Boom.
Yeah.
Stuff flying outwards in empty space. But that's not it.
That's the crucial difference, yeah. It wasn't like a bomb exploding in space. It was more like, well, the expansion of space itself.
Okay.
Think about drawing dots on a balloon that's deflated. Then you blow up the balloon. The dots themselves aren't flying across the rubber, right? The rubber surface itself is stretching, and that's what carries the dots farther apart.
Ah, I see. So the galaxies aren't really zooming through space away from a central point.
Exactly. Space itself is stretching between them, carrying them along. The actual fabric of reality was expanding.
That does flip the script. Okay, so if space itself was expanding, created even, does that mean there wasn't like an outside for it to expand into? What does that imply?
Precisely. That's where it gets really counterintuitive for us. There was no pre-existing void, no outside in the way we normally think about it, because time, space, and the fundamental forces of nature, gravity, electromagnetism, the nuclear forces, all of that seems to have emerged right then,
In that instant.
in that very first moment. Before that event, concepts like time or space as we know them,
Yeah.
they just didn't exist. They were born with the Big Bang.
Mind-bending stuff. Okay, so we have this incredibly rapid expansion, space itself unfurling, bringing the laws of physics with it. What happened next as this expansion kept going?
Well, as it expanded, it cooled dramatically. And this cooling was absolutely essential.
Why was the cooling so important?
Because when it was super hot, everything was just this chaotic, high-energy fuzz. Particles couldn't really stick together. The cooling allowed things to slow down enough for the fundamental forces to start, binding particles together. Think of it like steam condensing into water droplets as it cools. Without the cooling, you wouldn't get structure. You couldn't form matter as we know it.
Okay, that makes sense. Critical step, the cooling. So it cools enough for the first stuff to actually form. What were those very first building blocks? What emerged from that cooling soup?
The most basic subatomic particles could finally form stable combinations. Protons, neutrons, electrons. And then those combined to make the very first simplest atoms.
Huh.
Mostly hydrogen, a little bit of helium, trace amounts of lithium maybe. That's pretty much it initially.
Just hydrogen and helium, the lightest elements.
Yep, the lightest ones. These were the absolute foundational ingredients. Everything else, all the heavier elements like carbon, oxygen, iron, the stuff planets and people are made of, that had to be cooked up much, much later inside stars through nuclear fusion. So there's this amazing cosmic lineage, The simple stuff from the Big Bang becomes the fuel for stars, which then create the heavier stuff needed for us.
Okay, wow. We've covered a lot of ground, from a single point to the first atoms. So just to recap for you listening, the really key takeaways are that the Big Bang wasn't an explosion in space, but the rapid expansion of space itself from this incredibly hot, dense beginning. And in that process, space, time, and the fundamental forces came into being. Then, as it expanded and cooled, the very first simple atoms, mostly hydrogen and helium, formed. That set the stage for, everything else.
Exactly. And understanding that it does more than just explain cosmic history, right? It fundamentally changes how you might think about existence, about our own place in this vast evolving universe. It connects everything back to that single origin point.
So here's something to mull over. What does this mean for you? If everything, every galaxy, every star you meet came from that one point, expanding outwards not into space, but as space, and if the atoms making you up were forged from those very first simple elements, does that change how you think about boundaries? Or maybe how interconnected everything truly is? Does it maybe shift your perspective on the potential held within even the smallest, simplest beginning? Something to think about.